Hello everybody, my name is Sumanth Krishnamurthy and this is my submission for Machine Learning Foundations for Product Managers course project. In this project, we'll build a model to predict the electrical energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. We have over 9,500 hourly average ambient environmental readings from sensors at the power plant, which we will use in our model. AT stands for ambient temperature, V stands for exhaust vacuum, AP stands for ambient pressure, RH stands for relative humidity, and PE is our target, and that's the net hourly electrical energy output. We are going to be using Google AutoML to build our model. The first step in doing that would be to create a dataset. So we're going to create dataset, use the default name, select tabular, regression or classification, then click create. I select upload CSV files from computer and upload the CSV file that I showed earlier. So here you can see that a dataset has been created. I go back to dashboard, go to create a model. I've already created 3 different models, but I'll show how I went about in doing that. Go to train new model, select the dataset, select regression, AutoML, continue. I select PE as the target column, and the data split selection would be random. Continue. I didn't do any selections here. You can select what features you'd like to be included in the training, and to exclude something you can just go here and click this button. You can go to advanced options and select the weight column and the optimization objective. For my models, I had a couple of them set to RMSE and one of those set to RMSLE, and you can also set it to MAE. And for compute and pricing, I had 2 to 3 hours selected for each of those models. The model training time depends on the budget allocated. Model 2 is optimized for RMSLE and model 3 is optimized for RMSE. So we can go to model 3, go to version details, and see that the training time was about 2.5 hours for this, and the budget allocation was 3 node hours. Go to evaluate, go to eval model, and we can see that AT is the most important feature. A lower value of mean absolute error, mean absolute percentage error, and root mean square error indicate a higher quality model, and a higher value of R square indicates a higher quality model. So we can compare model 2 versus model 3. We can go to compare, add the evaluation model from model 2, hit apply, and we notice that model 2 is a better model because it has a lower mean absolute error value, a lower mean absolute percentage error value, and a lower root mean square error value as well, and also it has a higher R squared value. As this model is already deployed, we can change the values a little bit over here. We can give it 500 for example, and it's gonna come back with a predicted value. Now let's go back to the guidelines for the project. So for this project we used the regression model, and we used all features in the model, and we used 2 different algorithms, one optimized for RMSE and the other one was optimized for RMSLE. and Google AutoML automatically splits the data into 80, 10 and 10, and we used mean absolute error as a metric to define which model was better. There were a bunch of other metrics as well, but mean absolute error is the one that is most suited for this kind of a model comparison. And that's my project. If you have any questions, please don't hesitate to reach out to me. Thank you so much.